so we're back in section 9.1, trying to finish up examples, trying recursive, but they're way worse. We're seeing if we can make a recursive jump into easy formula. Okay, what'd you guys do for x sub 2?
X1.
Yeah, take the one before, plus 1/2 times 1. X sub 3 is going to be the one before, 1 plus 1/2 plus 1/2 squared. 3/2 plus 1/4. Times 2/2, 6/4 plus 1/4, good, 7/4. Third term. Or sorry, fourth term, right? We already had first term, I forgot.
2/16 plus, what's the other one? 28 over 16?
Wait, hold on, 7/4, right?
30
7/4?
over...
Oh, you're already doing the math. Are you doing the math?
Yeah.
So 7/4 plus 1/8. So I need 30 seconds? Oh no, just times 2. So 14/8 plus 1/8. 15/8. Does anybody see pattern yet? Kind of, sort of? Let's do another one. 15/8 plus 1/2 cubed equals 15. Oh no, fourth. 15/8 plus 1/16 times 2 times 2, 30 plus. Last one. The bottom is each getting multiplied by 2, by 2, by 2, right? 1 times 2 times 2 times 2 times 2. Yeah, multiple of 4.
Yeah.
So it's plus 4 plus 4 plus 8 plus. Not even a multiple, like a power of 4, huh?
Yeah.
Plus 4. Oh no, 8's not power of 4.
2.
I think
Plus 4 plus 8 plus 16.
2 squared.
Power of 2. Oh, okay, hold on, let's get this one. What's this one going to be? So it's going to be over
32.
32, good. And this one is going to be?
62. No.
no.
63.
Yeah.
Okay. Can we, this is messy, figure out a formula? This is where sequences got hard. You guys told me the easy one on bottom.
2.
2 and
Now careful, where do we want n to start? When n is 1. 2 to the 1 on bottom? Think about it. So at the first term, 1 minus 1, 0. 2 to the 0 is 1. Second term, 2 to the 2 minus 1. Oh, that's 2 to the 1. Third term, 2 to the squared. Fourth term, 2 to the 4 minus 1 cubed. Is that good? What goes on top?
2n minus 1.
2n minus 1? 2 to the n minus 1. Let's see if he's right. Wait.
No.
Oh, no. Minus 1. Got it. Not exponent minus 1. I was like, wait, Ethan, no. Let's try. 2 to the 1, 2. I'm starting at 1, right?
That's right.
2 to the 1, 2. 2 minus 1, 1. 2 to the 2, 4. 4 minus 1, 3. 2 to the 3, 8 minus 1, 7. 2 to the 4 minus 1, 15. 2 to the... Now, good, but hard. Makes it way easier. Because if I were to ask you for x sub 100, we have 94 more to go. Okay, right?
We can add
Or,
all of them
If
together.
I want x sub 100, I can just plug in 100, 100, 100, done. So which one is more useful? This one
Yeah.
or this one? This one more useful. Now, is it harder to get? Yes. But more useful? Yes. Now, good news is this isn't like a huge part of chapter 9, but it's reviewing sequences. Because sequences, we started first by saying, there's a pattern, look, I see it. Oh, it's not enough to see a pattern. We have to see if we can make a formula. Sometimes very easy, sometimes very hard. Okay. We're starting to get a little bit closer to notation. Let's use everything that we've done up until this point. I already gave you the hint that you can find the limits, okay? Let's not even worry about writing the first 4. I know you guys can do it, and we've done it lots, right? So, find the convergence or divergence of an infinite sequence. Find the limit of a convergent sequence. Okay, so it's just the words are a little bit different, but limit, we already saw that. We already see that it's a limit, right? So then, right, the first 4 terms, let's not worry about that. If they converge, find the limit. So let's talk about it. Ready? There's something missing. Can you guys put a little n right there? There's a little n. As n goes to infinity. So if the terms go to L as n goes to infinity, this is something we're going to use. A function of a sub n is going to approach a function of L. That's something we're going to use. But we're trying to figure out convergence or divergence. So guys, let's just make sure we're good. Ready? Part A, what's it converge to? You all agree? 0?
Yes.
So far I've heard Layla. Anybody else want to back her up?
Yes.
Do we need to write? Hold on, let's take a second. Anybody, are you guys writing? I'll pause. Does it converge to 0?
Yeah.
Mm-hmm. Limit is 0, right? This will be online too, so if you just want to focus in, it's totally fine. You can focus in and then come back later. Next one. Converge or diverge?
We have the same.
Converge.
Converge, because they have the same.
Exponent.
So if we took derivative, it'd be 5th, 4th, 3rd. -7 is at the end. Degrees are tied, right? Degrees are tied. How about next one?
0.
Good. Next one.
The top wins.
The top wins.
So,
So, if I took, right, we can take limit.
Yeah, it's gonna be infinity. So, a divergence.
Mm-hmm. If I was to use L'Hopital's, just to prove,
Okay, 2n.
2n over 1. Oh, guys. 2 times bigger numbers? Is that converging? No. Sequence diverges. I'm just shortening for sake of time. How about this one?
what does it say?
Yeah, let me zoom in. That didn't work very well, did it?
Bottom one.
It's
Convergence.
5 times n over 2 to the n.
Maybe.
Converges to 0.
Why, Keiki?
Because it's gonna, you're gonna use L'Hopital's and
Yeah.
it's gonna be just to the end. Then 1 over 2 to the
Derivative of 5n?
5.
5. Derivative of a to the u is a to the u times ln of a times u prime, n prime just 1. Uh-oh. What's the very next one going to be? Derivative of top, 0. Derivative of bottom, still ends. Bottoms are going to be get bigger, 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 but top's going to be 0, so therefore right? This one I never actually finished writing. Okay, I think we've done tons of sequence work, right? We had sequences by plugging in calculator and seeing how we can go to table and see what's going on as I get bigger, 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 bigger number terms. Then we started writing out terms ourselves and seeing if we can do it without the calculator. Then I kind of introduced early. We saw limits of terms. Okay, sequences, no big deal, right? Sequences are easy. Not these ones. These ones aren't easy. Doesn't mean that we can't do them, because we can with L'Hopital's. Some of them. We can do some of these with L'Hopital's. Like the first one, couldn't we do L'Hopital's?
Yeah.
Infinity over infinity. Ah, no problem. 1 over n times 1. Oh, 1 over n times 1. 1 over n divided by 1. With L'Hopital's, that's going to be n going to infinity. That's 0. Do you need to memorize? I don't know. You can use L'Hopital's. How about the next one, though? 2 to the 1 over n, 3 to the 1 over n, 4 to the 1 over n, 5 to the 1 over n. As long as x is greater than 0. So not negatives, because negatives make everything difficult, right? Plus square root of negative is bad. So 2 to the 1/2, 2 to the 1/3, 2 to the 1/4, 2 to the 1/5, 2 to the 1/6, 2 to the 1/7. What's it getting closer and closer and closer to? 0 or 1?
Oh yeah, 1.
As n goes to infinity, this part goes to 0. 2 to the 0 is 1. Ooh, interesting. The next one we already saw yesterday, and Ethan actually looked ahead for us, and we put it in our calculator, and we got 2.71, and it started getting really weird, all these weird decimals. Hey, what did it end up equaling? It ended up equaling E.
Is there a possible way to zoom into these?
However, something is different. Do you want me to read anything to you, Lena? Where are you
It's
at?
okay. I forgot 'em.
It's not just E. It's going to be E to the X. Now, if this was 1 over n, E to the 1. But if this is 2 over n, 3 over n, 4 over n, 5 over n, it's E to the X. It's E to the X. Think about this one, the nth root of n. Uh-oh. So 2 square root, 3 cubed root, 4 fourth root, 5 fifth root of 5, 6th root of 6, 7th root of 7. Uh-oh. I can make it n to the 1 over n. That might make it a little easier to remember. If I was taking the limit, n goes to infinity of n to the 1 over n. Well, guys, bigger, 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 raised to smaller, 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 smaller.
It's gonna be 0.
1 over n is still going to 0, but bigger and bigger numbers going to 0.
It's a
1.
1.
Anything to 0 power?
Oh yeah, it's 1.
I know, our brain says 0. No. X to the n. Now wait a minute, hold on. If this was 2 to the n, or 3 to the n, or 4 to the n, infinity divergent doesn't converge to right? Has no limit. But what if x is in between negative 1 and 1? 1/2 to the n, 3/4 to the n, 5/6 to the n, negative 3/4 to the n. 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, 1/128, 1/256, 1/512, 1/1024. I chose that one because it was computer, so easy ones to do. 0. But anything else besides x is in between negative 1 and 1? Nah. Diverges. The sequence diverges. And then we saw this one, right? Who was stronger? X to the n or n factorial? N factorial was stronger, so 0. It's still the same idea. Who's stronger? Top stronger or bottom stronger? N factorial is stronger. This is endeavor number. Are we on 13 or did we do another one
I
already?
think it's 15 this one.
Did we skip some?
No, I thought we did 14.
Improper integrals was 12. That was chapter 8. Chapter 9. Did we have anything chapter 9 yet? Does anybody have their endeavors written down? Let's check. Where did we end? I think it's 13.
This is number 15.
Oh, what was our last one?
The surface of rubber.
Oh, surface. I haven't had Chelsea do it yet. Arc length and surface. You're right. Endeavor number 15, guys. But I need you to do something. I need you to box sequences because sequences are not series. Sequences. So logical. Limits of terms. Easy. Series. Okay, you got it? Endeavor number 15? I need you to box sequences. Special converging sequences. Okay? Sequences. I never filled this in. 2 to the 0 is 1. Or approaching 0. Can I go on? So, let's use our new, I don't know. Let's use our new endeavor card. Ready? Just sequence. Limit as n goes to infinity of ln of n squared over n.
0.
You sure? ln of n over n.
Yeah.
Same thing. Who's slower? Or who's bigger if I go to infinity? And if you didn't believe me, what could you do on this one? You could do L'Hopital's. You could say, if you don't believe me, now not all of them, you could do 1 over n squared times 2n all over 1. Well, guys, even though n squared, still perfect. You got it. 0. How about the next one?
One.
But how can you prove it to me? Can't I do?
The power is going to give 0.
Can't I do like that? Wait, same thing? Same thing. Yes. Yes, same thing. Or you could say n through n times n through n, and what are each of the n through n's going to? Where is it? N through n? N to the 1 over n? Going to 0 power, which is? 1. So, 1 squared is? I can say this is going to 1. 1 squared is 1. Right? How about the next one? How can I use my property? Is this legal?
Yeah.
Right? I can split up if it's times or dividing. I can't split up adding or subtracting, but I can split up times or dividing. So, what's this going to? 1. 1 times, wait a minute, 3 to the... Infinity, still going to 0, right? So then 3 to the 0 times 3 to the 0 is 1. 1 times 1 is still 1. I'm showing you how just our few basic ones can help us. Our few basic ones can help us. Guys, look at our special converging sequences. How about part D? How about negative 1/2 to the n?
0.
0. Negative 1/2 to the 1, negative 1/2, 1/4, negative 1/16, 1/32, negative 1/64, going to 0. Number next one, let me see if I can zoom. Can I zoom in at all? A little bit. Try and make it so you can see better. How about this one? How do I use my special converging sequences on this one?
Each of the
Why? What did you do? It does have an E. How can you tell?
Because n over n minus 2.
Each of the negative 2?
Sometimes we have to rewrite it to see it. N over n minus 2 over n is 1 minus 2 over n to the n. It's going to be e, but it's going to be e to the power of...
And the negative, it doesn't change anything.
Oh, is it negative? Should I put positive?
Yeah.
Ooh. Hold on. Kaiki's exactly right. I can't go to E yet. Doesn't fit my formula, but what can I do to change the negative to a plus? Now does it fit? 1 plus x over n to the n? Yes, it's going to be e to the... e to the negative 2. And then last one. Who wins? 100 to the n, or n factorial. N factorial wins. N factorial is stronger, like exponential growth. It might not look it for a long, long time, but eventually as you get bigger and bigger and bigger.
Misty. Why we can take the
Double check though. X to anything to the n over n factorial wins. What'd you say, Ethan?
or we can take the negative 2.
I'm not taking negative 2 out. I'm saying plus negative.
Yeah, but
Plus negative is same thing as minus.
yeah, I know, but why is
Because I have to make 1 plus x over n to the n, I have to make it fit my formula.
x? Oh,
I have to make it
X.
fit 1 plus
I think it's
yeah. Does that make
I
sense?
think always 1.
Oh, it could be 1. If it is 1, e to the 1. But if it's 2, e to the 2. If it's negative 2, e to the negative 2. Now, kiddos. This is where we're going tomorrow. This is section 9.2. This is section 9.2. I'm actually going to split it off. So we got there. We got there to 9.1. Homework tonight, 9.1. It might not be quite as crazy as what you're seeing, but I'm getting you ready for what's coming next. So we have special converging sequences. Homework. Who's already done with homework? Done?
Almost.
No, 1 more.
One more?
55.
Almost?
Yeah.
Okay, we'll do questions tomorrow. Sound good? My ones who did it tonight. Get on top of it.
Missy.
It can be study break. So study, calculus break, and then study. Okay, I'll check that. Monotonic means strictly only going up or only going down.
Oh.
And then bounded is whether or not there's a limit.
Oh.
Does that make sense? So bounded, like boundary, if I'm your boundary, you can't go past me. So bounded means like a limit, and then monotonic means only going up or only going down. Does that make sense? Homework tonight.
Okay. What's your top one? Did the top one machine run Amazon, or did they have to go
They
in?
have to go in there. All I know is that we was like, had issues, and Seattle was like, they didn't even bring it in. I know, they didn't even bring it in, and so they gave me one. And then they didn't plug in, like, they didn't turn on everything, turn on the turner and turn on the heat.
Do you think that should I ask them?
Yeah, I would ask you like 10 minutes early or 15 just to make sure it's good. Ethan, sorry.
The one is being
If you can't text whoever's supposed to, someone like Nikki was supposed to go to the
so the one is being the vertical horizontal. So
horizontal.
horizontal. You mean divergent. And
Oh, it's physics.
I have comp sci, but if I ask to leave 5 minutes early, because I have a meeting today, so I told them that I would go and make sure it's on so that they can be there, and then I can just go to the meeting.
That's okay. Ask me later.
So do you think if I go 5 minutes early and just start it, that somebody will be there, like when it starts, to make sure that it's. Yeah, I